Hello students, so this is Sri Balamurugan. I'm your physics faculty. Yeah, so we are going to get into the topic chapter dual nature of radiation and matter. So this is completely a different notion that we have discussed with respect to the chapters we have discussed in the electricity, electrostatics, electromagnetism, magnetic effect, and induction, everything. So it will deviate little bit different from the complete of the chapters whatever we have discussed right now. Yeah. So what is the chapter mean? What does the chapter says? Dual nature of dual nature of radiation and matter. What does this mean? See, they are saying something like there is a radiation, it has dual nature, and there is a matter, it has a dual nature. People used to read with the name like this. Yeah. So I can say radiation, like I'm just considering some radiation that is UV rays and light rays, different colors of light rays and everything. You can say all this consider this as light source. Let me say light source. And matter it is something like a particle. Yeah, particle means, like, let me say something called a proton, neutron, electron, everything. So I can consider anything as a particle. I can consider this mouse also as a particle. I'm just now considering this matter with respect to microscopic level. Like what are the microscopic level? Something proton, neutron, electron. All these are the microscopic or nano level, nanometers in the level. Yeah. So what is that saying? See, radiation, that is light rays. That is, let me show from this one. Yeah. Let me say from light rays, they are saying something called dual nature. See, what is the dual nature? What are the dual nature? So let me say here, the light rays, we know it has a wave nature. When we on the light, see, there is a light source here, so only you can see me, because due to the light that's scattered with respect to the wall, whatever the objects here in the room, I'm just getting visible from your eyes. So how does this light travels? Light travels in the wave format. We have discussed, we know this one. We know this from the grade 10th also. So, but I'm saying this light rays as a particle nature. I'm saying light is also a particle. Like I'm saying something new. See, there's a light. I'm considering light as a particle. How can I consider it as a particle? It is massless. I cannot see somewhere. I'm just feeling it from myself. I'm just getting something as I can see the whole place is visible because of the light source, and I'm saying it is a particle. How come it is particle? We know it is massless, but how I'm saying it is a particle. How come? So that is we are going to discuss in the dual nature. That is what we are going to discuss in the dual nature. So I am saying light is not only a wave nature, it has also a particle nature. And I am saying the matter respect to electron, proton, neutron, everything. So all these things has a particle nature. It is something particle has something mass. We know something electron has some certain mass, proton has certain mass, neutron has certain mass. Yeah, everything has a mass. But I am saying all this particle move in a certain wave format only. Moves in a certain wave format only. I can say it moves in a wave format only. How I am saying it is moving in the wave format? That is what we are going to discuss in the dual nature. So the topic says dual nature of radiation matter. What is the dual nature? Wave nature and particle nature of this radiation, that is light source, and the matter, that is electron, proton, neutron, all those microscopic level particles, functions dual nature, both wave nature and particle nature. So it behaves both also. How come all this comes? We are going to discuss. Don't worry, we are going to discuss. Okay. So yeah. So first I'm going to discuss with So first I'm going to say the radiation, that is light source. How I'm just explaining some experimental point of view. In 1900s before, there is a person called Hertz. I will take some person into our picture, so you can understand step by step how does they get evolution, and how does we find it out in certain point of time. So initially we doesn't know this dual nature. before getting to know this dual nature, there is a person called Hertz. Hertz. You have learnt in the previous chapter electromagnetic waves. Yeah. So what he said, the light projects EM waves, that is electromagnetic waves. That is, what is the electromagnetic waves? The magnetic field and the electric field are perpendicular to each other, and it possesses the electromagnetic waves format. Hertz says this one. So how does he find out all these things? He just performed one experiment. Like there is a, let me say, yeah. So there is a voltage here, yeah, and it is a spark generator. Okay, what is this spark generator do? It generally create the spark with respect to higher voltage that is generated with respect to the two wire here, and I'm just having a metallic ring that is, sorry, yeah, I'm just having the here metallic ring. Okay, yeah, I'm just having a metallic ring. So whenever the spark gets generated, so it travels from here to here in the medium, yeah, in the space medium, and I can visible the spark here, and I can see the spark here. So whatever the spark I see here, whatever the spark get created, I can observe from the metallic ring. This we have learned in the EM waves, but it is happened in certain room. So I can consider this box as a room. In a room, like consider I am in my room, I am just performing this experiment. Okay, now what I am doing, he done some accidentally. What he done, he just turn off the light. So it is now done in without light. So no light source are there. So I am just performing the same experiment without light, and he have observed something different. What he have observed? Something, the spark size get reduced. So whatever the spark before he got and whatever the spark now he got without light, it get reduced. How come? It just made a complete opposite, complete phenomenal change about the understanding of the light sources and the matter sources. Matter will come after. So just now look it with respect to radiation. So the light source, that is, the spark get reduced. So this is the first stage of photoelectric effect. So I will come into the terms hereafter, the word photoelectric effect hereafter, but I'm just introducing this word now to make you understand and comfortable. Okay, so you may get a question, how does this comes? Why does this place? Okay, I will give you another one scenario. Okay, there is a person called Hallwalk. Okay, Hallwalk. Don't want to remember all this person's name. Just understand the concept clearly, so you can understand the equations clearly. Then you can further proceed with respect to the questions, solving higher order questions or everything. You can solve easily. Okay, so just to have a concentration with only the concept now. There's a person called Hallwalk. He come into the picture now. So what he done, he took certain, yeah, let me take this color. Yeah, so he took certain metal. Okay, and here it is negatively charged. Okay, it is, let me say, zinc. Okay, zinc, he took zinc metal and it is negatively charged, and another one the same, it is positively charged. So what he done, he just scattered the light. Yeah, he just scattered the light. Violet rays, violet rays has the higher frequency, so we know, right, violet rays. I will explain why violet light that gets scattered, why he done this violet light now. I will explain later. Okay, so just understand some light sources scattered in these two metal plates, that one is negatively charged and one is positively charged. So what he observed, the Hallwalk, what he observed, after a certain interval of time, he observed this zinc plate get uncharged. The negative charge went away. It is completely uncharged. There is no negative charge left in the metal, zinc metal. When he comes into the play of positively charged zinc plate, he observed the same number of positive charges are there in the zinc metal plate after a certain point of time, t. So what we have observed here, what understanding did you get? Like there is some light sources, and that scattered in these two different metal plates. One is negatively charged and one is positively charged. When one get uncharged, one get the charge that leave out from the metal surfaces. Why this happens? Here, consider this light sources as a photon. Okay, photon. So the new word comes here, that is called photon. Okay, so the photon is like, consider it is as like something like a positive particle. See, consider it is a positive particle. Don't want to go into further something in a deeper. Something is a positive particle. Okay, so there is a series of photon. It is massless object. I cannot see. It is massless. This photon has a series of photon that is gets scattered in this metal plate, and it acts like a positive particle, and it took away this negative charge from attaching the positive, and it directs away the charges from the metal plate, that is negative charge. If I consider the photon is a positive charge now, if it gets scattered again, I can say this is already positive charge. Why come it should take the positive charge again from the metal plate? So it leaves the positive charge as it is, and it just go away. So what I can say, due to the light source, when there is a sequence of photon, the negative charges get emitted out. So I can say here from the before experiment, Hertz, what he observed, in the presence of light there is a spark that is generated in the equal amount what it gets generated in the higher voltage in the circuit. But when there is a light that get off, he just to find out the spark size get reduced. So if there is no light sources, there is a less number of electron get emitted from the metal surface. So due to that, the size of the spark generated get reduced. If there is a light source, the number of electron get ejected or more, so I can get the equal amount of spark that is get generated in the wire when there is a higher voltage. Okay, so this is the complete principle. So I am saying something like, when there is a light source, when it get heated on the metal surface, if there is some electron in the metal surface, it will try to emit out, and it will make that as a positive charged metal plate, if there is a positive charge in the metal plates. Okay, so here we will come across different number of different number of keywords, that is work function, frequency of the metal plate, frequency of the light, and everything. So we will come across many different keywords. Don't worry, it will be everything easy, but try to understand, when I try to hit some kind of intensity and frequency of the light to the metal plate, there is a emits of electron. So what I am understanding, so light does not behave only as a wave nature, it also has a particle nature. Why? Because something called photon as a particle, it hits on the metal surface and it leaves out. So I am saying it is a positive. I am considering it has also a particle nature. So this gets proved from the experimental procedure. Okay, so this is the complete concept. Yeah. So that's all for today's class, and I will discuss the next topic tomorrow. Okay.